what I did was I got together all the polymers I could think of and ground them up, made them into powder, and then heated them up to see if I could make a panel that was nice and clear, that would mimic glass, and break easily by hand, and was safe. And not being from the design background and an engineer, I wasn't versed in chemistry, or I might have reached some conclusions quicker, but when you're a startup company, you don't have the luxury of the university funding. The next step is to mold. So this was our early injection molding factory. This is an oven at home in my kitchen again. Now I share my premises with another organisation known as my wife. And when I first started to experiment with these polymers, they obviously made a hell of a smell in the kitchen. I had to move premises within about 2 weeks, because obviously my wife was not at all happy with what was being produced. And very quickly moved to a garage. Now, we didn't have a garage at the time, we had a shed, we didn't have a garage. But there was a new housing development up the road, and they were selling houses with garages. So I decided to go down and have a look, and managed to persuade, at a very reasonable cost, one of the vendors to sell me a house with a garage. Obviously the house just came with a garage. I only bought it for the garage. My wife, she got the house, I got the garage. And years later, I still maintain that our second house, we wish had a double garage by this time. It was really bought for the double garage. So this is what we were producing out of this prototype manufacturing production plant that was going on. Now, yes, we did sell this. Here's a slight improvement in the production. Before we were sticking it in the oven and melting the powder down, and here we're using, it seemed to work better with heat from underneath. So this is an iron turned upside down, and at the time obviously we had great fun imagining how many irons we could fit in per square metre to make Safeglass panels. We eventually ended up making, this is the quality we were making with the iron system. We weren't using an iron, we were using a griddle, which I managed to persuade my sister-in-law to give me from her pub. She was throwing it out. It's one of these griddles that you make hamburgers and you can fry things on it. So it's basically a big block of metal, so like a big iron. Now the picture on the right is our very first product, our product sold product. And it was sold to the Glasgow Underground. The part on the left is the same product that's on the right, but we covered up all the bubbles and the black bits and the yellowness with paint. This as well, because they wanted green parts. But obviously lots of customers that we were sending samples to, and our samples were no better than the one on the left. And because the process of making these samples was so long, because it takes about 2 hours or 3 hours to cook in an oven, we could only make very small samples. And my sister, who works in the business, she's our marketing manager, she says, Rob, we need 300 samples by next week to send out to this list of potential customers we have in the UK. So I said, well, you know, we can't possibly make that many with one oven. So I then contacted other friends and family about using their ovens. So that we did in fact manage, out of necessity, manage to make 300 small parts within a couple of weeks and get them all sent out. And ladies and gentlemen, I mean, this is what you have to do when you've got no money and the banks won't give you any. Finally, this is the Mark II. So the money we made from Mark I products, we reinvested into Mark II products. And this allowed us to do things like make injection molds and tooling and get proper R&D funding and get the universities involved and improve the product. The product at the top is, if you like, the final Mark II product. In fact, the product hasn't really changed much from that formulation. So, this is our compounding now on the right, proper compounding machine. But equally as well, Working on the left is a few kitchen implements. I'm not going to tell you about one of our failures. Obviously, if you want to make pieces of glass, it sounds credible that you should make a big sheet of glass and then cut it into smaller pieces. Now, our market is for, as I showed you earlier, is for small pieces of glass. It certainly would be more efficient if we cut it up from big pieces. So this was our first attempt at making big pieces, and this is just a standard sheet rolling machine. And the top left-hand corner is Safeglass is running out the die onto the floor. Now these machines run rapidly, so you have to put tons of material at one end, and then about 30 seconds later, it all runs through the machine, comes out the other end. In this case, onto the floor. So we went several times and ran several tons of material onto the floor before we understood the material and how we could get it through the rollers and make sheet. And you can see the other photograph sheets coming out. Fine, great. Why was it a failure? Well, it wasn't making the sheet itself or working with the polymer. It was simply the handling of the sheet when it came out, because it's very brittle. It's like glass. And the way that traditionally these machines would work is that it would use a guillotine to cut the sheets at the end of the line. But what happened with Safeglass was when the guillotine came down, and the picture on the bottom right, that's the guillotine there. When the guillotine came down, it basically smashed the Safeglass to pieces. And not only that, it sent a wave up the rest of the line and smashed all the material all the way back to the rollers. So we were asked if we wanted to pay £100,000 to develop a machine that would cut, take the place of a guillotine, but we just declined. We were only 2 or 3 years in by that time. But we may go back and look at this again. Fabrication. Now, as I said before, you can take sheets, or small sheets or large sheets, and you can cut them up. But I say that now with hindsight. At the time, we didn't know how to do this. We tried everything from waterjet cutting, laser cutting, cutting in saws. We tried everything. And finally, we hit up on the idea of using a very fast router. And here is the first prototype machines that we sort of experimented with. I say prototype machines. These are actually production machines. We are actually manufacturing them. It's about Mark 2 or 3, this machine, this wooden MDF affair on the left, that's for cutting up. You can do one straight cut, you put it down, you push it forward, it does a cut, you turn the pan around and you cut off the wastage, and you should get a square or a rectangle panel cut down from another larger square or rectangle panel. The machine on the right, but the contraption on the right is for making round panels, and quite simple, you put in a blank, you adjust the router, which is bolted to the side of it, and you turn the handle, and it makes a round part. So that's where we were, sort of early days, experimenting how to cut it up. Nowadays we use CNC machine cutting. It's all high tech and clever people to program it. Here's an interesting story. This is the breakable switch seal going. I showed you this before. This is not so much a story about the innovation of the material or the processes. This is more of a material of getting it to market quickly without spending too much money. Now we knew there was an application for these things, but we weren't willing to lay down the tooling. We are a Scottish company, so there's a certain amount of skinflintishness about us and not wanting to spend anything. And quite right too, because we might not have survived in business. We might have been one of the 9 out of 10 and failed if we hadn't and not spent any money. So my wife enters the story once again. She was out shopping. It's an activity she loves, so as all women do, I would suggest. And she brought home one day some swizzle sticks.